Hi folks, today I bring to you liquid crystal display with two drivers. This liquid crystal display, if you take attention, you will see it sometimes I bright only the right side or other the left side. The drivers use it to control this LCD. One is the responsible from the left side, in this case is LC75878, and the right side is LC75808. And the question more frequent about this solution to control the same LCD with the two drivers, but use the same pin of data to control these two drivers, is how can do it, how is possible send the information to the left side or the right side with the same pin of the processor responsible to send the data to the LCD. And I will try explain this how this work. I have done a small draw with the schematic of the connections of the two chips, and if you take attention here, you see the data in this side go to the resistor, and after connected the data to the is coming from the processor. Okay, the other side you have also the same pin data in, which go to the resistor, in this case is 470 ohms, and go to the processor with the same pin. Okay, also you can see the chip enable from these two chips is connected direct from one side to other side and go to the processor. The clock is exact same situation. Okay, the clock is connected from one chip to other chip and go to the processor, which is then the responsible to make the difference from the left side to right side. If you look to the address of these chips, you see the processor in the left, the 75808, have address with the reference 014010, and the right side, the 75878, have the word of the address, or in this case the byte of the address, the chip, with 01010. By this reason, when you send a message, the first byte is sent to the drivers of the LCD is the address you want to reach. If you send this byte, you reach the left side. If you send this address, you reach the right side, or vice versa. I don't know now which is the right or the left. But the idea is you select the chip you want to polarize the segments with the byte address, and after you send the message, and the chip responsible to this address receive the message and implement in the segment pins. Okay. Also, you can see here this chip, the 75808, have the data out, and the 878 don't have this pin, because this pin have the possible to implement a matrix key, which you can read the stats of each key, read the data out. The right side, or this driver, don't have the possible to use the matrix key. By this reason, you don't have the data out. Anyway, if you use another chip which is have the matrix key, and you have the data out pin here, you do it exactly the same thing you do it with data in. Okay, the data in go to the data in, the data out go to data out, and after is connected to the same pin of the processor, and you need to take care with the configuration of the pin out data out of the processor and control the stats if it is write to the drivers or if read from the drivers. Okay, I already have this solution implemented in the other videos about the drivers. Okay, and now about the control of the LCD. You see, I'm using the left side and the right side only to explain and to show the all segments of the LCD. Here is all present, and after I do it a small animation and present here some words only to exemplify how is the aspect of the display. One of these drivers can control until 480 segments, and the other can control until 600 segments. Of course, you have the control stats of the driver, and you have the possible to switch on, switch off, sleep mode, dimmer the bright of the LCD, and draw segment by segment to represent the shards you want. In the code, I don't construct with a table of the shards. Which I have done is construct or fill the each block of the bits I send to the display with a specific bit to fill or to draw the shards I want to represent. Okay, but of course the correct way to use these drivers is do it a table, for example ASCII table, and after send the selected shard you want to send to the drivers. I do it by this way because it's more easy to the people adapt this code to the other situations of hardware which control the LCD like this. Okay. About the connection of this panel, you can find in the below side of the PCB the two connectors to the satin cable, and all the pins you need use have a point test which you can connect your wires to the breadboard. Okay. It's necessary to take attention about the light of the back panel. You have the plus 12 volts here connected to the point of the illumination, and here you have GND, and I like do it alert about the GNDs of this panel. You can find here 3 GNDs. You have GND of logical level. You have the GND of the ASD, electrostatic device, and the GND of the backlight to illumination is this point here. You can find also one pin out to do it the control of the dimmer of the back panel. Okay. This is point here. You need to connect the dimmer to the GND with a resistor from 10 kappa, for example. And you can find also the INH, which is necessary you put to the VCC, and you have also the 2 pins from the VLCD from each driver, which is necessary to do with the equalization of the light controlled by each driver, okay? Because one driver have one level of the segments, and other can have a small difference. And to avoid this kind of the gaps between these two chips, is necessary equalize the VLCD, okay? But you can connect these two signals VLCD to one resistor, for example, the 1 kappa to the VCC, okay? And this is enough to solve this part. And the other chips you have is chip enable, clock, and that's all, okay? After you connect these wires, you can bring to life the LCD.